This video is going to be a short video talking about different kinds of sampling. So remember we talked about the fact that the population are all the items under investigation. So if you wanted to predict who was going to be the next president of the United States, then your population would be all the registered voters in the United States. Now, likely you could not contact every registered voter in the United States. That's just not practical. It's just too many people, would take too long, cost too much money. You simply could not find everybody. So instead, you'd want to pick a subset of that population very carefully called a sample. All right. Now, how you pick that sample, a lot of times predetermines the possibility of whether your study is going to be any good or not. So remember what we said, that sample needs to be kind of a mini-me of your population. So if your population was mostly males, but your sample was mostly females, there would be no way to generalize from your study back up to the population you're trying to represent. So that population and that sample, they just need to be different in size. Okay, so how you go about doing that is really important. So when I'm reading a study, if I glance and see that their sampling's not good, I stop reading the study because it's not worth it. Okay, it's just our conclusions will not be valid. So there are lots of ways of taking samples. We're going to talk about 5 probably of the most common ways. Okay, so I'm going to kind of share my screen with you. It's just a real short PowerPoint to give you some things to kind of put in your notes. Okay. All right, types of sampling. And again, you need to take notes as we kind of go through this because it'll be on your test. Okay, the first kind of sampling is something called random sampling. Now, sometimes one of the problems we have in mathematics is words in math don't necessarily mean the same things that words mean outside of math. Like if I said, well, that was just random, then that might seem to be haphazard. But that's not what it means in mathematics. Okay, so a random sampling doesn't mean just a haphazard sampling. A random sample means that every item in the population has to have exactly the same chance of being picked. So every item in the population has got the same chance of selection. And that's harder to do than it sounds. All right, think about it. If you want to predict who's going to be president of the United States, why could you not just randomly start pulling cell phone numbers and calling them? Because every registered voter doesn't have a cell phone. There's probably somebody sleeping under a bridge right now that is a registered voter, but doesn't have a cell phone. So he or she has no chance of being contacted. So you do not have a true random study. So do you see what I mean by it's harder than it sounds? So every item in the population must have exactly the same chance of being selected for it to be random. So it's a great way of sampling. It's just often difficult to do. Okay. Now, systematic sampling is, and let me go back to this for a second. With random sampling, let's just pare it down a little bit so it's a little easier to think about it. Suppose I live in Clinton, Mississippi, and I just want to predict who's going to be the mayor, the next mayor of Clinton. I could get a list of every registered voter in Clinton. Okay, that is public knowledge. Okay, so I could go to the city and get a list of every registered voter. Maybe that list is numbered from 1 to 27,153. Okay. I can't even go, I'm going to pick person 52. I'm going to pick person 2,475. Maybe person 11,000. I can't even do that and it be a random study. Because you have hidden biases that you don't even know about. I mean, no self-respecting Southern Baptist is going to pick 666. Right? We all know, Satan. Okay. So you have biases for and against numbers that you're probably not even conscious of. For instance, for some bizarre reason, if you just catch me off guard and say, give me a number, I'm almost always going to give you a number with a 4 in it. I do not know why, but 4 apparently is my favorite number. Most people won't use 13. Think about it. A lot of hotels don't have a 13th floor. A lot of times it's the last row in a plane to fill up. We're superstitious about certain numbers. People will pick even numbers more than odd numbers. They don't tend to like prime numbers, okay? So mostly if you want a true random sampling, you're gonna have to get a computer to be involved in some sort because humans have hidden biases. The computer could randomly spit me out 700 numbers between 1 and 27,753, okay? But I can't just think of them. All right, systematic sampling is where every nth item in the population is picked. So again, if I have that list of 24,753 names of registered voters in Clinton, if I pick every 115th name on that list, so 115, 230, 345, and so forth, if I start picking every 115th name, that's what systematic sampling is. But again, I can't pick N because I'm not going to pick 666. So the computer would have to give me a number, 51. That means every 51st name on the list, I go down and pick for my study. Well, now sometimes that's a great way of sampling and sometimes it's not. Now think about why. Suppose, well, for instance, my husband worked in a Westinghouse factory between the summer of his senior year and the freshman year of college. He wasn't sure if he wanted to go to school. Okay, so he got a summer job. Now, he spent 8 hours a day screwing a screw into a hole on a lamp. That's all he did for 8 hours. Stood in the line, never moved. There were about 15 of them. The lamps would come on this assembly line and stop. He put a screw in, they would go on. The next one stopped, he put a screw in, they went away. Okay, so about 3 weeks into it, he decided college would be great. Now, I'm not dissing factory workers. My mother worked in a factory all of her working life, but it is hard work, okay? Now, think about if I'm quality control and I'm trying to make sure I'm getting some good lamps. Would it make any sense for me to stand at the end of that assembly line and check every third lamp that comes off that assembly line? All right, do you see why that would not be a good idea? I mean, if all 15 of us are standing in the line and we don't move, and I'm checking every third lamp every time, do you see I'm checking the same person's work? It might be that third person is excited, they love their job, they're just compelled to make a really good lamp, putting that screw in good and tight. It might be the seventh person still on holiday, so to speak. Okay, it's Monday and they haven't gotten over the weekend yet. So in that case, it would really be better if I did not do systematic. So it wouldn't be good sampling in that situation. But back to that mayor of Clinton, it would be fine to pick every 13th person on the list. That's probably a great way. So some studies, systematic's great, some studies it's not. Okay, so that's why there are different sampling techniques. Random sampling, if you got the money and the time, good all the time. Okay, now let's talk about two other kinds. And these are the two that people tend to get confused: cluster sampling and stratified sampling, because both of them involve groups. Okay, so with cluster sampling, the population is divided into groups, and then individuals are picked. I mean, groups are picked, not individuals. Okay, so think about a cluster of grapes. So rather than picking individual things on cluster, you're picking groups of things. So the population is divided into groups. So you pick all of this group and all of this group and all of that group, and none of that group and none of that group and none of that group. All right, so that's why I say all of some. All of some groups are picked and all of some groups are skipped or not picked. Stratified, and think about strata like in geography, like strata like layers of the earth. So the population is divided into groups, but this time you pick some out of each group. So that's why I say sum of all. So some of every group is picked and some of every group is skipped. And then your fifth way is called convenience sampling, and convenience just means it's easy, it's useless. It's just completely useless. So it'd be like if you went in the cafeteria and just said, who are you going to vote for? That would be convenience sampling. Now, let me kind of go back to these two because that's where people get confused, and give you kind of an example. Suppose I was doing a study about 8 o'clock classes on MC's campus, and I thought maybe, I mean, do people at 8 o'clock make worse grades because they're sleepy? So I go to the registrar's office and I get a list of every 8 o'clock class for the whole semester this fall of 2021. And I pick, there are 25 classes on that list. And I just randomly pick Dr. Park's class and Ms. Lassiter's class and Dr. Burns' class. And I use all the people in Dr. Burns' class and all the people in Ms. Lassiter's class and all the people in Dr. Park's class. But I don't get anybody in Dr. Major's class. I don't get anybody in Dr. Travis's class. That would be cluster sampling, because all of some classes are picked and all of some classes are skipped. Stratified sampling would be if I got a list of those, say 25 8 o'clock classes, and I randomly pick 10 students out of every one of those 8 o'clock classes. So that's what I mean by all of some and some of all. Now on your homework, what's going to happen on your homework is you're going to have some examples to kind of go look at. If you have trouble telling the difference, then email me and I'll help you with that. Okay, I hope it helps.